Hey everyone, and welcome to This Explainer. Today, we are going to completely demystify artificial intelligence in healthcare. Now, I know that for a lot of medical professionals, this sudden explosion of AI can feel, well, like a totally alien landscape. It's moving fast. But here is the absolute best secret. You really don't need to start from scratch. Nope. Instead, we're going to build a gentle, logical bridge from a world you already know and trust deeply, the world of biostatistics, straight into the future of AI. By the time we wrap up today, you'll have the exact mental framework you need to confidently evaluate the tools that are literally transforming modern medicine. Okay, let's dive into this. We've got a very clear 6-part roadmap to guide our journey today, keeping things super structured. We'll hit 1. Physicians above the tools. 2. The Biostatistics Foundation. 3. Why cross the AI bridge. 4. AI is not monolithic. 5. Decoding deep learning. And finally, number 6. Evaluating and trusting AI. All right, let's kick things off with Section 1, Physicians above the tools. You are the central arbiter. Right now, there's this massive, almost overwhelming tug-of-war happening between big tech algorithms and proactive patient care. But amidst all these crazy promises, we really have to establish one absolute truth right out of the gate. Everything else is just a tool. This paraphrased quote from Hippocrates perfectly grounds our entire topic today. Medicine, at its very core, is always about the patient, not just the disease, and absolutely not just the algorithm. As we plunge into this era of hyper-personalized medicine, your clinical expertise in actually understanding the individual sitting right there on the exam table, well, that's the one thing algorithms literally cannot replicate. Moving right along to Section 2, the Biostatistics Foundation, the bedrock of causal evidence. Let's start with what you already know incredibly well. For over a century, traditional biostatistics has been the trusted language you've spoken to validate clinical decisions, right? You use it all the time for causal inference, basically answering the big question: does this therapy actually improve outcomes on average? You rely on formal hypothesis testing, those trusty p-values and confidence intervals to gauge uncertainty. But here is the absolute critical limitation for our modern era. Biostatistics strictly requires clean, structured, labeled numerical data to give you that average treatment effect. Which brings us to Section 3, why cross the AI bridge? Handling the high-dimensional world. So if traditional statistics are so magnificent, why cross the AI bridge at all? Well, the answer comes down to what I call the yes but rule. Yes, traditional stats are fantastic for causal evidence, but they kind of hit a brick wall when faced with modern, messy, highly complex patient data. And this brilliantly illustrates the exact shift we're talking about. Biostatistics deals with structured data and average effects. Artificial intelligence, on the other hand, shifts the whole paradigm over to personalized prediction. It actually thrives on the messy, multi-dimensional whole picture of an individual patient. You're going to hear the term high-dimensional data thrown around a lot. Simply put, this is complex, unstructured information. Think of a beautifully messy, handwritten paragraph of clinical notes scrawled at 3 a.m., or the intricate audio waves of a patient's voice, or a highly detailed MRI. You absolutely cannot just neatly drop a chest X-ray into a traditional statistical bell curve. It just doesn't work. High-dimensional data requires totally different computational muscle, and AI is built specifically to process this massive new influx of unstructured information that just can't be reduced to a simple number on a chart. Let's move to Section 4. AI is not monolithic, the rule of 3. Look, AI has become this massive catch-all buzzword slapped onto pretty much everything these days. But as a clinician, you cannot treat all AI the same. When someone pitches you a shiny new software tool, this is literally the very first question you must ask. What is it actually doing under the hood? Like, is it predicting a number? Is it looking at an image? Because honestly, the answer completely changes how you should evaluate and trust it. Let's break this down into 3 distinct flavors. Flavor number 1 is machine learning, or ML. You can think of this as the natural formalization of statistical learning. It excels at recognizing patterns across millions of data points to predict outcomes. For example, by crunching massive amounts of electronic health records, vitals, and lab results, a machine learning model can actually predict a specific patient's risk of developing sepsis in the next 8 hours. It's a huge leap. It transitions us right out of biostatistical inference and straight into dynamic, personalized prediction. Then we have flavor number 2, deep learning. And this is where things get really fascinating. Deep learning relies on advanced neural networks that don't just predict things, they actually perceive them. They extract higher-order representations from all that unstructured, high-dimensional data we talked about a minute ago. So instead of manually programming a computer to know what a tumor looks like, you feed it millions of scans and it literally learns to see the patterns itself. It brings true perception, like vision and speech recognition, directly into our clinical toolkit. Now, what's really interesting about this slide is our third flavor, generative AI. This is the technology powering tools like ChatGPT. Rather than just predicting a number or perceiving an image, Gen AI actually synthesizes brand new content. It takes those learned representations of language and structure and builds actual reasoning models to generate text, draft clinical notes, or even help structure complex differential diagnoses. It acts like a highly capable cognitive assistant, though, and this is a big though, it's one that absolutely requires your expert critical supervision, because yes, it can hallucinate. On to Section 5, Decoding Deep Learning, from numbers to perception. Let's move to and see how this builds. It's really like climbing a conceptual staircase. Level 1 is inference, handled by our trusted biostatistics. Level 2 steps up to prediction, driven by machine learning. Level 3 adds perception into the mix through deep learning, allowing systems to actually interpret complex images and sounds. And finally, Level 4 reaches generation through Gen AI. It's just a beautiful, incredibly clear, logical evolution of analytical capability. And finally, our last section, evaluating and trusting AI, the terminology cheat sheet. To confidently step across this bridge we've been building, you just need to slightly shift your vocabulary. Think of this table as your ultimate survival guide. In biostatistics, your primary goal has always been causal evidence, right? But in AI, it's all about pattern recognition. But look closely at the metric of doubt. This is huge. In traditional stats, you look for a confidence interval to understand the uncertainty of a general estimate. In machine learning, however, you're looking for a prediction interval that tells you the specific uncertainty of a specific prediction for the actual individual patient sitting right in front of you. So, the crucial point is this. AI is not here to take your job, but a physician utilizing AI will very likely replace one who refuses to adapt. AI is here to inform you by processing massive, high-dimensional data that you couldn't possibly compute manually. It's here to augment you by acting as a tireless, 24/7 cognitive assistant. It's here to accelerate your daily workflow so you can spend a lot less time typing and way more time actually caring for people. But hear this loud and clear. It will never, ever replace your clinical judgment, your moral accountability, and your deeply human bedside reasoning. So, as you walk back into your clinic or hospital today, I really want to leave you with this provocative thought. You are now equipped with the map. You know the crucial differences between traditional stats and modern algorithms, between basic prediction and advanced perception. The bridge is officially built. So, how will you apply your own irreplaceable clinical judgment to the very next AI tool you encounter? Thank you so much for joining me for this explainer, and keep learning.